So I'm just going to quickly run over the work I've done for this dripping LED effect using an ESP32 and take some MIDI messages coming in and converts those to drips, displaying on a LED NeoPixel string. Now this generative plugin was a previous work. It basically, all that we're plugging into is this nodes object, the start stop, and it itself is just sending MIDI messages to the plugin that's been worked on here. Now this plugin, basically we are setting the addresses that we need, fairly self-explanatory, and this UDP receive here will be receiving from the Touch OSC app. Now this is taking the command kick, snare or hi-hat, routing that to a hue, saturation and value or lightness. This is converted by multiplying by the float 255 and then packing into an integer list, as this 0 to 255 integer is what our ESP32 expects. And now this list is stored here in this message box as a temporary storage to then be outputted depending on what notes played. And so in this case, those notes, which there's not much control over, but I know that 36 is the kick, 37 is the snare, and 42 is the hi-hat. So I can associate each of those to the color that we're receiving depending on that command. So if we go into our Touch OSC, I've just got it running on the local host so that we can see how that works. When we're changing the hue on this kick, then you can see that hue over here is changing. Same as that saturation, same as that lightness. And now that means when a 36 happens, that's the color that we're getting out. Now, how does this outside change? That's the second component here. We're prepending which from this trigger here. So we're saying, hey, send a hi-hat, set the prepending to be a hi-hat, and send that symbol with box color. So how does that come through? In this function here, whenever we receive an OSC message, we check whether we're matching that box color, and then we get the second component of that message, which will be, hi-hat, snare, kick. And then that allows us to locate within the children, which this is just the root object. So we're going into the panel, into the panel's children, into the panel's child with the name of whichever group it may be, kick, snare, hi-hat, into their children LED color, which is just this outside panel, and then setting the color on that to be equal to the rest of those arguments, which the rest of those arguments, that list, I've written this JavaScript here, which converts it over to from hue saturation value to RGB. Pretty rough approximation, but just gives a good idea what's going on there. We'll look at this accelerometer data. This is a script people may have seen before, just takes the 3 accelerometer datas and sends them as the 3 values of a OSC message to this address. So the second thing is looking at the ESP32, which we're sending just a color message and this /drip command to, as well as this / this is going to the ESP32. When we're receiving this drip or accelerometer XYZ command, we're using an OSC library that allows us to assign a function to either of those. So if we're handling a drip, we store up to 3 drips in a structure. This structure exists as next drop. We can store up to 3 in that, which means if we receive 3 things hitting at once, say a kick and a snare at the same time, even if they happen on the same frame, we can make sure they're both included in that single LED drip process. So down in this loop, if we do have some ready, so if more than 0 are ready, then we basically just average together the colors. Otherwise, if this loop won't trigger if there's only one ready. We'll only be setting the first LED to the values we're received. And then we can show that. So we're doing that once every frame delay, which, say for 60 frames per second, is just under 20 milliseconds. Now the accelerometer data, on the other hand, that when we receive it, we're just storing one value. So if many updates happen, once we've received one, we stop collecting them. We also cap it at -1 and +1 just to help with the later calculations. Now these calculations are the same ones they use on an aeroplane, just to see the roll and the pitch. And it's some trigonometry that you end up being able to have an angle both rolling over the longest edge and then also rolling over the shortest edge, so flipping a full circle. This leads to calculating a global hue and global saturation modifier, which is how you can see in this next video it modifying those colors live. And that's basically how the ESP32 is processing our data that we're moving around. Lastly, we just have some basic controls from within this app back, which is, again, the direction of communication from the app to our plugin, which includes this nodes object and this syncopation value. And these two are fairly straightforward. It just controls this as well as these syncopation values here. And that's routed from this, so we send everything that doesn't match over to a receive that then just passes that data to the correct location, as well as this toggle. That basically is the implementation, and I hope you enjoyed seeing how this has all come together.